Tanner, and no one else. Uh, Look at what photo just popped up on my watch right then. Just two sad people. Google memory. All right, here we go. This is what type of reaction? Tell your lab partner. Double replacement. You guys are amazing. So we split the couples right here. So BA now hangs out with who? S. Oh, no. No. No, you didn't. No, no, you didn't. NA hangs out with Jared's mom. All right. Then we got to balance charges. +2, -2, +1, -1. Ooh, that was easy. So then I do these things. A 2 in front of NaCl. Amazing. She is amazing. All right. Great question. So why did I keep the 2 here? It's because the 2 didn't belong to Cl. It belonged to the charge of Ba. And so it brought its charge across, but since now it was hanging out with something that was a -2, we didn't need anything. Uh-oh. It's begun. You need to, you need to go to the bathroom? Does that make sense, Devin? Devin, did that make sense? Oh, my. Curtis, sorry. I don't know why I called him Devin. It's twice today, actually. Curtis, did that make sense? All right.
Hey, are you recording?
Yeah, I am. See that little red dot right there?
That was on the recording.
We're all good. Okay, I don't need to change anything else, right? 1, 1, 1, 2. Okay, who got that correct? Start to finish. Raise your hands. Okay, well, those 3 people are ready for the test. 4, sorry, 4 people. Everyone else, you definitely need to rewatch yesterday, come into B time, take the practice quiz online, which probably isn't published yet. But there are resources. You have till Friday. Okay, the rest of the hour is our introduction to stoichiometry. Stoichiometry is like comparison math. And I know that sounds weird, but it's actually pretty cool. We can do a lot of things with it. So this is page 9, maybe. What page is that right there, Tori? Nope. 10? Page 10 and 11. So today our goal is to get through moles to moles, which is a piece of cake, and moles to grams, which takes a tiny bit more time, but isn't that much harder. All right, the first thing I need you to believe me is this stuff is not hard. Goddard is super wrong. I don't know why he sells it like it's hard. This stuff is harder than what we're going to do.
You gotta climb stairs, and if you don't know this, you're gonna hit a wall.
Yeah, I've been fighting his wall idea forever. It doesn't make sense. Just trust me. It's not that bad. If you follow my process for doing it, it's really easy. I wrote a song about it. Did I sing it yesterday? It's called Follow the Process. Sing it? I don't remember all the words, but it's something like follow the process, follow the process, follow the process, and you won't get it wrong. And I don't remember the rest.
That was pretty good.
Thank you. No, it's not. It's a stoichiometry song, Curtis. I don't know what you're smoking. All right, here we go. So I don't know where Devin even came from. Yeah, I'm sorry. Here we go. Do you guys know what this thing is?
That's a bicycle.
All right, this is a bicycle. Sort of pay attention here. If you look, it's not super hard to understand that a bicycle requires a frame and wheels, and it makes a bike. Now, have I used this analogy before?
Yeah.
Okay, so then we're like, hey, that's not balanced. I know that the bicycle needs 2 wheels. So in order to make a bike, I would balance it by putting a 2 in front of the W and then a 1 in front of everything else. So 1 frame, 2 wheels goes to one bicycle. All right. All we're going to do now is we're going to change something and then ask what that does. So if I am a bike maker and I have 50 wheels, how many bikes can I make? I just divide that in half, right? And that equals 25. We okay with that, sort of? All right. Now, with a bike and wheels, we wouldn't ever have to do this. But when we use chemistry terms, it seems a little bit more confusing. So we're going to use this thing again, and whether you loved it or hate it, I don't care. It will help you a lot this trimester. So what you do is I gave you 50 wheels. That's the problem. I have 50 wheels. I want to know how many, well, it would just be W because that's in the equation. You with me? I want to know how many bikes, which is FW2. So what I would do, I would put this unit at the end, FW2, and I'd take this coefficient and I'd put it here. And then I would put this unit here and its coefficient underneath. 50 times 1 divided by 2 tells me from 50 bikes I can get 25, or sorry, from 50 wheels I get 25 bikes. That is all we're going to do today. Well, it's not all. We'll make one tiny bit more change. And it requires an extra step, but it's not any harder. All right? So when we do this, just think, oh, those are the wheels, these are the frames, and whatever. Now, a brief discussion on moles. For some reason, kids don't like moles. All right? I don't really know why. It's just a number.
Because the mole was the bad guy that one hamster. G-force, I think.
Good point. Okay, sorry. So it's G-force. I need to go back in time and stop that movie from being made. Okay. All right, well, I can't. So here we go. Moles are not the devil. It's just a number. So don't overstress it. Now here is a life changer. Anytime we have been balancing a chemical reaction, we have used coefficients. Coefficients are actually referring to the number of moles that we are using in the reaction. So you were fine with a 1, a 2, and a 1, but for some reason you're offended when I say 1 mole, 2 mole, 2 mole, 1 mole? Well, that's dumb. Don't. So, what? Okay, okay. I'm sorry, I ignored your feelings. So look here. Look right here. 1 mole of BaCl2 reacts with 1 mole of Na2SO4 to form 1 mole BaSO4 and 2 moles of NaCl. These numbers all along have been our moles. So we can compare them, by the way. In this reaction, what? Oh no. It's all right. It happens. We've all had a bloody nose in school before. Let's go here. I'll get it just a second. We can compare mole to mole here. Like for every one of these I react, how many of these am I going to make? 2. Every 1, there's a 1. I make 2. You can't see it, but there's a 2. We can compare these things. That's all we're going to do. All right, so stick with me. We're now on page what? 10. 10 and 14 are quite different. That's all right. Holy, that's not just a little bit, Tanner. You okay? Like, apparently. Is the carpet going to be this bloody? All right. Don't look. I got to get the other stuff. Hold on. If you would, you can start by balancing that equation. What?
all balanced it already.
Oh, it's already balanced. Golly, what a blunder. All right, so balanced chemical equations give us proportions that can be used for predictions. So, hold on, let me clean this up.
Have you cleaned up a crime scene before?
Yes.
You're like the guys like John Wick calls. The first one when he has to clean up his house.
I have not seen that.
That's probably this thing. It's pretty heavy.
Might not be old enough for it, is what you're telling me.
Yeah.
Yeah, you're probably right.
Actually, no, you don't want them all. I'd probably have like a
It's kind of cool to watch hydrogen peroxide and blood react.
What is that like hemoglobin?
Uh-huh. All right, here we go. That is hydrogen peroxide. It's a great cleaner of blood. Okay, back here. So these are
Good one, buddy.
kids these days. Don't call him Devin anymore. You're gonna get me confused, and I'll call him Devin for the rest of his life on accident. Okay, here we go. If 2 moles of S are used here, how many molecules of SO3 can be made? 2. If I give you this and it has the same answer, then the answer is the same. Looking up here, if 2 dozen S atoms, ooh, that's a 2 again, how many dozen SO3 can be made? 2. Weird. 2 dozen. Well, it asks dozen and dozen. Number next is tricky. If you only have 1 of these, how many of these can you make? 1. This ratio, it's a 2 to 2 or a 1 to 1 or a 10 billion to 10 billion. Like these 2 numbers will always match. Next, if 3 moles of O2, we switched it on you, how many SO3 can be made? 2. If this is a 3, this tells me it's a 2 right here. It's a 3 to 2 ratio. So these numbers will tell me the comparison of each one. Okay, coming down here. All we're doing is taking the numbers in front of these things and putting them on these lines. So the molar proportion of S to O2, I just take the S, which is a 2, the O2, and I put a 3. The middle one, SO3, I put a 2. Moles of S, I put a 2. Next, SO3, I put a 2. O2, I put a 3. So these are the proportions. For every 2, I get 3. For every 2, I get 2. For every 2, I get 3. Now, I could flip it. I could say for every 3, I get 2. For every 3, I get 2. Okay, these are proportions that we can use in our beautiful picket fence. Okay, you're all right. Okay, so first thing on A, will you balance this to start with? You just got here from Pakistan?
Nope, you talk to me like that.
I'm sorry. India, my fault. Okay, raise your hands if you have it balanced. Raise your hands if you have it balanced. All right, girls in the lab, nothing? Okay, well, I'm going to balance it now. I'm going to put a 3 right here, a 3 right here, a 2 right here, and a 1. 3, 2, 1, 3. Who had that right? Okay, now, my friends, this stuff, please, this thing that he calls the wall, it's not hard. Just do exactly as I tell you, and it's really a piece of cake. So first, balance the equation. We did it. Next, start in the upper left-hand corner with the given number in unit. So look here, if you have 6 moles of aluminum, well, you're going to put 6 moles of Al right there. That was so close. So just put 6 mole Al.
Good job, Travis.
All right. Now, you're going to do that every single time. Balance it and then start the picket fence with the number and the unit I give you. Okay, next, fill in the picket fence by canceling units until you get the desired unit. If you get stuck, go in reverse. We won't get stuck today, but we'll see what reverse means. So what I mean by this, I need to look, what answer does this want me to get? It wants moles of Cu. So you may remember from first try, please, please, this unit always goes down here. So this is moles of Al. Now look at the screen. The number that is moles of Al comes from right here. There's 2 of them. Then, what do I want to solve for? Moles of Cu. So I put moles of Cu, and the number in front of that is a 3. And then I do the math. 6 times 3 is 18, divided by 2 is 9. It gave it to me right here. The start will always be given to you, word for word, number, number, unit, unit. It will tell you everything at the start. Okay, so we start with the given. We find out what we want to the answer. And then we work the picket fence from left to right, solving it out. All right, let's do another practice one. So if I have Ca plus O2 goes to CaO, and I want to know, is there space anywhere on that page you can do this problem? Do it, okay, do it at the very bottom. And it wants how many moles of CaO if you have 28 moles of O2. So according to my steps, the first step is to balance it. Will you balance it yourself real quick? All right, it is a 2, a 1, and a 2. Okay. Then, how many moles of CaO if you have 28 moles of O2? So I start with the number and the unit it gave me. 28 moles of O2. Now, my friends, I'm going to say this a ton. The unit here always goes where? Down and over. The unit here always goes down and over on every single one of them. So I have moles of O2. All right, well, where do I get the number that goes in front of moles of O2? I get it right here. So it's 1. And then I want moles of CaO. So this would be mole CaO, and that number can be found right there. So I take 28 times 2 divided by 1, and I get 56. That's definitely not the hardest thing you've ever done in your life, right? Okay, well, you're not even doing it, so you do not count. Here we go. Homework time, number 36. Good. When did you have Goddard's class? What? Oh. Then why are you in it this year? Oh, well, that's unfortunate. Okay, 36. Will you try it on your very own? First, balance it. Then put the number here, unit here, unit you want. Answer. Ready, go. What? Yes. What's that? How many moles of nitrogen monoxide? So that's NO. So it wants to know moles. Yeah, the oxygen is the O2. Light work, huh, Jared? Okay, you can go to the one underneath it if you're already done. I like that. Curtis gets it. Jared.
Good job, Curtis.
No. Okay, when you're done, raise your hands. All right, I'm gonna go on then. All right, I already did it through the magic of technology. Hopefully, I'll have it. Let's go a little darker here. That one. Okay, so I had 5 moles of O2. So I needed to get rid of O2, so I brought it down, which was it was a 1, my fault. This was a 1, and a 2. All right, so I wanted moles of NO. So I did go down and over. Did you bring a 5 right here? Don't bring the number. It's just the unit that goes down and over. It's just the unit. All right. So then we have the 1. Then we have the 2. So 5 times 2 is 10. Okay, who had that right? All right. Okay, let me get rid of all that. We'll go to the next slide. This one is kind of pointless, but it's all right. We can practice the process. The neutralization of an acid with a base is a double replacement reaction in which a salt and water are formed. Okay, well, I know it has water because it said. What would the other thing be here? So it's double replacement. We already have water, so it would be left with NaCl plus 1 minus 1. So it's all balanced already. These are all 1s. Okay, will you fill this in and find me an answer? All right, here we go. So I take the number and the unit I was given and I start with it. 25 moles of HCl. Now, I wasn't very clear, so let me just reinforce. I always take the unit down, not the number, just the unit, moles of HCl. I find the number here by looking in front of HCl, so there's a 1. Then I need to find out what I want to solve for. It asks how many moles of NaCl, so moles, NaCl, and this unit will always match the end unit. And I can find that number right here is also a 1. So this was super pointless math. It's 25 times 1 divided by 1 equals 25. No, not really. Like it tells you like it explains the reaction, but really all you need is this part. It is cool though. You take an extremely strong acid and an extremely strong base, and you just make salty water. Okay, who had that one set up? All right, good. Uh-oh, Curtis, no? Did you have that one set up right?
I did.
Okay. All right.
I didn't feel like I had to set it up because propane one.
All right. I get that, but be careful. One thing that teenagers do, and it's fun, like I understand why, you're lazy. You'll go like this. You're like 25, because you know that. But if you don't put the unit here, well, you don't know what goes here, and you don't know what goes here. Like, include the unit. You'll get lost if you don't. Okay, the next one. Woo-wee. This is a combustion reaction. C8H18 plus O2 goes to CO2 and H2O. These are the ones we've practiced a few times where you start with a 2. Then the other 3 steps are on page 12. You give that your best shot for a second. Did you get a 1 and a 2 and a bunch of zeros? What? Yeah. Seems crazy though, right? That's a big number.
Yeah, that's why I was nervous, but then I realized it's chemistry. I can't be bothered.
Yeah.
The worst part is if I get it wrong, you'll just give me the right answer.
That's why we struggle on tests. It's because I train you to just wait till I do it for you.
I do it before you tell me how to do it.
Yeah, you did. I watched.
And then, if I'm wrong, you should tell me how to do it, and then I see why I'm wrong, and then I passed it.
All right. Good job. I'm going to balance this, and then you can do this. So the next step was to balance carbons, 2 times 8, so you put a 16 here. Whatever the number is with hydrogen, put it in front of water. Then balance oxygens, 16 times 2 is 32, plus 18 times 1 is 18. That makes 50, divide it in half, and you get 25.
Gasoline.
Octane is the gasoline, that's the C8H18. Okay, then you're ready to set this up. You want moles of CO2. I'll just put that right there. And I'll give you 1 minute to finish that. What's that?
Oh, yeah.
It's okay.
I didn't read.
Yeah, it is a very large number. Okay, when you get it, check with your partner.
I'll come back to you. Yeah, perfect.
Oops. All right. How many of you had 1,200 moles of CO2? Raise your hands. All right. Did you get it? All right, Devin. Oh gosh. See, no, that's his fault. That was his fault. All right, Curtis. I knew Jared was going to ruin my life. Um, when I took chemistry in high school, I'll be completely honest, I hated it. I hated it. I took it from the trainer, like Mr. Burgraff. Now, it wasn't Burgraff, but the trainer couldn't care less about chemistry. He cared about sports. We did one lab the whole time, didn't like it at all. But then eventually I took physics and I loved physics. And when you get to be a teacher, they require you to get you have to have two majors. And so physics and chemistry sort of overlap. So I went with physics and chemistry. Now I ended up loving chemistry. This is what I like about physics and chemistry. It gives value to math. And I like math, but I think it's completely pointless. Like nothing against your friends underneath me, but there's not a time in your life where you're just like, all right, square root of 15 I times whatever. Like there's just no. But then I took science classes, and the harder the science classes got, the better I understood and appreciated the value of math. And I know that's the super nerdiest answer ever, but it helped me connect a whole side of my brain and got me excited to learn more about it. So I like the math. The next couple days are my favorite time of the whole year, because we take chemistry, which is kind of interesting to me, and we take math, which you can finally see that math does matter, especially in physics. Physics is really good at explaining math. I don't know how we teach it here, if that happens or not. Anyway, it just really all came together with me about my second year at college in physics. And I thought, wow, science is awesome. No, I went to Skyline High School down in Salt Lake, home of the Eagles. I'm sure you all care. But anyway, that's why I use this class. I hope that you leave this class with a more positive view of science and a lot better ability to solve complex problems and not to be afraid of them. And then I also hope you leave this class not scared to take your next science class. Um, I don't know. Yes, I did know that. I'm gonna I'm gonna buy that land. Just kidding. I can't. I'm a teacher. I'm gonna buy bread and water for dinner. Just kidding. I got my taxes back and I made a lot of money last year. I won't tell you the number, but I am not ever going to complain about my money. It was more than $7. Good guess. Okay. This is not homework. This is back to the notes. All right. So what we're going to do over the next couple of days, if you look at the screen for a second, we started a picket fence that just had a plus sign. Then we're going to get a picket fence that has 2. Then we're going to get one that has 3. They don't get longer than this. Now, if you just stick with me, a minute ago, we said we start and that the unit here always goes down there, right? And that the unit at the end is always the unit at the end. We're just going to do the same thing. We're just going to add one more thing. And look, the unit right here is going to go down here. And the unit at the end is going to match the unit at the end. And I could also, if I felt like it, I could keep on going and that would go down there. And the unit at the end would be the unit at the end. Like I can do this unlimited amount of times if I needed to, but we won't. So first, balance if you have not yet. All right, so two H's, that makes two Cl's, that makes two Cl's, one iron, one sulfur, one sulfur. Will you raise your hands if you feel pretty good about balancing now? Hopefully we've gotten to that point. Okay, now I'm going to follow my process. I'm going to take my number and unit and start here with it. 1.8 moles of HCl. Now, what's nice is if I know this unit here, I also know this unit here is moles of HCl. Where do I get the number for HCl? Tell your partner.
Right there.
Oh, it's right up here. 2. Okay. Now, remember I said a little bit ago, like, keep going. If you get stuck, go in reverse. Does that sound familiar? Okay. Now, some of you aren't stuck, but I'm going to teach you when to go in reverse. In chemistry, a lot like driver's ed, I never want you to guess. And then you're like right here, like, oh, I don't know what goes there. I think I get, no, don't. There's something that will tell you what goes here. Just follow me here. What is it asking me to solve for? Grams of H2S. So watch what I'm going to do. I'm going to put grams of H2S here. All right, now that means this unit here is what? Grams of H2S. Now, we'll find this number in a minute. Anytime you have grams in a picket fence, it will always be per 1 mole of the same thing. So these grams, they are always per 1 mole of the same thing. Then look at the screen for a second once you've written that down. Do you see this unit right here? Where does it go? It can also go up. And then we have this. Did someone say that's whack? I'm offended. Oh, whack is a good thing? Okay, never mind. And this is whack good? Okay, there we go. It was epic. All right. Okay, so look, the units right here, they will always match each other. So if I know the bottom, I know the top left, or if I know the top, I know the bottom right. They go together. Okay, so now we need this number, which is a review from part A. So take out your periodic table pretty quick. This is from first try. It's super not that bad. You've done it before. All right, when we need to find the grams of a formula, we go to the periodic table and open to the middle. We need the middle one. And you'll notice in H, there's a 1 and a 1. And in S, which number's on top, big or little?
What? There's 32 and 16.
32's on top and a 16. I just want to make sure I matched you. Okay. The big number is the mass. Does that sound familiar from part A? Okay, so I have 2 hydrogens, and the mass of one of them is 1. Plus, I have 1 sulfur, and its mass is 32. So the total mass of H2S is 34 grams per 1 mole of the same thing. What are you laughing at over there? I feel bad. I just gave up on him.
Yeah, I was gonna wait one, but he probably needs.
Yeah.
So
Yeah, we'll be good. Okay, so this is what I need. I need the 34 per 1. I already have the 1, so I need a 34 right here. Okay, then I do the math. 1.8 times 1. If you type that in your calculator, you have issues. All right, times 34, and then divide that answer by 2.
wait, you wouldn't just do 1.8 times 1 divided by 2 and then do.
Then do 34. You could. I just always go all the way across and then divide by anything on the bottom. What do we end up with?
Odessa.
30.6. Odessa, have you ever seen the Saturday Night Live where they talk about Alexa for old people? Oh, it's so dang funny. Yeah, but at the end, it's just like old grandpa. And he's like, Odessa! And it won't answer. Odessa! Anyway, so whenever he says your name, I think of that dumb skit. So when we wanted a number and you were like, Odessa, I was like, oh, this is real now. It's happening. Okay, I know that was a lot, so let's do another one. Number 40, yes.
No, I had bad news.
Number 40, balance it out.
I forgot I can't make that. Yeah, right, dude. I don't broke Micah's ankle. And Austin. Yeah, that's what part skills.
Let's see if this will work.
So funny. All right,
Amazon Echo has everyone asking Alexa for help.
Alexa, what time is it?
The room is already 100 degrees.
Nice. That's pretty good actually. Amber, hopefully that was good. Ashton, hopefully that was good. We didn't finish this problem. I started showing a stupid video.